So that's game theory, reinforcement learning, control theory. So you're basically trying to characterize the individuals. Well, you're trying to characterize the interactions, then maybe the individual strategies, then the sort of the way in which it's controlled, and then causally controlled. So, I mean, yeah, this is a nice sort of chain of things that you would use to explain different aspects. It almost seems like reinforcement learning might come before the game theory because you have reinforcement
Yeah,
learning for the individuals. They,
yeah,
they set up their strategies, and then the game theories where the strategies are implemented. Then the control theory
correct.
might be like where the strategies are, how do they get controlled, like at the level of the strategy. So your reinforcement learning is where the strategies are being selected as viable. Game theory is where it's being implemented in an interaction. Then your control theory is kind of explaining that, and then causal inference is saying what is causal and what is maybe correlative, because we
Right,
don't know
right.
what is causal. We have to do these experiments where you have to maybe ablate something or do an intervention where you have like some action on the system as an external observer. So, this is a nice, if we could kind of figure out how this fits together. And if you had, like, say, for example, like an individual or maybe a population of individuals. Let's take the example from the genetic algorithm. You had a population of individuals, and they all kind of course, there's variation in how they achieve something. And that's kind of the point of evolution is that you have variation, and then it gets selected or it gets bottlenecked through some sort of uh, uh, drift process or something like that. But basically, you have this variation in the individual agents. That's like going to be, you could use reinforcement learning to characterize it. You could use a genetic algorithm to characterize it. You could use other kinds of methods too. Um, but that, you could swap that out. And then you have the game theory where you have your strategy suite, and the strategy suite would be maybe continually updated from the reinforcement learning. So we don't know, like in biology, we don't necessarily know all the possible states, all the possible
Possible
strategies.
outcomes. Yeah,
We
possible
might
outcomes.
we might generate new ones, and then the game theory would test that out and see which ones are stable. And then control theory would be building on top of that, where you'd have a controller. Like in the controllability literature, they're really looking at what neurons. Well, in the paper that you showed, what neurons or what nodes control other nodes. Basically, which nodes are the hubs in the network, and then those control that set of interactions. So you have this kind of interesting connection between control theory and game theory, where you could use controllability, or you could use some control, uh, you know, strategy. Basically, you're looking at how game theory is working downstream. What nodes are
Right.
being affected by a certain strategy being implemented. There's also this connection between control theory and reinforcement learning too, because reinforcement learning is where you are kind of reinforcing different strategies, or you're reinforcing a policy, and you're saying, if this policy is pursued, it's rewarded, and then that's kind of the one that's selected. And so in control theory, you're also kind of making sure that feedback is reinforcing the proper, the system being within the proper parameters. So there's that aspect of it too. And then causal inference is like narrowing down everything and saying, what are the causal relationships there? What is like, what is actually causing what, or is it just kind of like, random? You could have like a random reinforcement learning and a random control theory. It wouldn't be very good, but in biology, it might generate something interesting, and we can't say whether or not something is causal. So that this is nice. This is a nice architecture for this. Um, and then there's all this math that you have to do to kind of,
Right.
yeah, but I think
Yeah,
actually,
the math part is the difficult part. So like in my proposal, I just explored the hyperbolic space, which is like one math part, and I explored that in depth. These are like four things. So like if I have time like later, and like if I get selected, and like later if I have time, I'll have to like explore all of this and like connect everything in depth.
yeah,
So
yeah,
like yeah, definitely, I
but
would be interested to do this. This was just an intuitive and a uh, overview of everything as to what something can be done from a different point of view. Like while making my proposal, also I felt that okay, I'm going deep in one thing, but what if there's something else which can model same thing? Like of course, biology is something which came about itself. Like this is not which is model. Mathematics is something which we develop. So we are trying to fit biology in different models. So that is what was coming to our mind. Like, I'm fitting it in one model, but what if some other model fits it better? So yeah, so this was just a try to find other models where I can fit biology in. So yeah, if I have time later, I'll of course try to explore all these models and just try to get something good out of this.
yeah, I almost think it's more interesting to look at, like, instead of looking at the math, look at like some sort of simulated biological system, like create a agent based, almost like an agent based model or something with agents in it,
Right.
where you're just doing that. And you don't, I mean, you don't necessarily have equations. You can maybe work out the equations, but like just demonstrating how it works in that sort of model where you have a population, you have variation, and you have these things going on that kind of control the, or how these things play a role. Because people will. Some people sometimes will do papers where they make claims and say that, like, biology is doing reinforcement learning, or biology is doing, well, reinforcement learning comes from biology originally, but so that's kind of obvious, but like it's doing game theory or it's doing control theory. And of course, the idea is that's a theory. It's not really a thing that we know is biology. We're interpreting that from the biology. So, but we could build agents that, like, say, okay, this is how an agent would behave under this theory, and it fits pretty well. And I think it's a lot more effective than just kind of saying this is supposed to work. um,
Yeah.
yeah.
Makes sense. Makes sense. Makes
All
sense.
right. So yeah, this is great. Thank you.
Yeah. Thank you for listening.
Yeah,
And yeah, sorry for the like I did miss on some details. I didn't go into like some details of some stuff, but yeah, it's
it's
just have.
okay. That's okay.
Okay, thank you.
You're welcome. Yeah. So yeah, I have actually here. I'll show you something here.